So really, we'll be dealing with our Taylor series. And for Taylor series, the short formula is written as the summation from n equals to 0 to n equals to infinity of the function of n, differentiating that function to the power of n, or still leaving the function the same way, of c divided by n factorial into x minus c into brackets raised to the power of n, where n starts from 0, like we said, till infinity. And the expanded form of this formula is f of c plus f prime of c, which is we have to differentiate that function once, f prime of c into x minus c plus f prime prime of c into x minus c all squared divided by 2 factorial plus, and it keeps going on and on like that. Now, one thing about Taylor series is we know that we are dealing with the function itself, differentiating the function once, differentiating the function twice. We could keep continuing as much as we would want to. So for f of x is equals to ln x, we are giving this function f of x as ln x. So we are asked to find the expanded form at c equals to 1. Remember, your c is equals to 1. So now you go here and write f of 1, where our c is 1, is equals to ln 1. And ln 1 gives us 0. F prime of x means we have to differentiate the initial function. And differentiating ln x gives us 1 divided by x. Now, at c equals to 1, f prime of 1 implies 1 divided by our x is 1, which is equals to 1. Now, f prime prime of x is equals to, differentiating this function, we could use a short form to differentiate this function by saying we change the sign of the number on top to a negative number and then writing it as 1 all over x squared. Or we could use the normal method, 1 divided by x is equals to x to the power of minus 1. And differentiating this, we are going to say minus 1 multiplies x to the power of minus 1, and then we subtract 1 from the power, which gives us minus 1 x to the power of minus 2, and all this all together gives us minus 1 over x squared, which is the same as the initial thing we had. So moving on, we are going to put our c equals to 1. This implies that minus 1 over our x is 1. 1 squared is equals to minus 1. Now let's do the third time of x. Differentiating this function again, like we said earlier, we will change the negative sign to a positive sign first of all, and then use the power of x to multiply 1, which is 2 all over x to the power of 3. Then we add 1 to the power of 3. Or we will say this is minus 1 x to the power of minus 2 from here. Now, differentiating this with respect to x gives us minus 2 multiplies minus 1, and then we have x. Remember, in differentiation we remove 1 from the power, minus 2 minus 1. This gives us 2x to the power of minus 3, which is equals to which is equals to 2 divided by x cubed, which is the same as what we have. Now this gives us f prime prime of 1 implies 2 divided by 1 cube, which is equals to 1. Now we could decide to do this as much as we would want to, but since we have the first one, second one, third one and fourth one, we could still do it the fourth time, the fifth time, or leave it this way. So having it this way, the expanded form of this, the expanded form using Taylor series, this gives us, we go back to our initial function, this is equals to f of c initially was 0 plus f prime of c, we had that to be 1 into x minus our c initially was, our c we're given is 1, x minus 1 plus f prime prime of c, which is minus 1. F prime prime, we differentiated twice, we got minus 1 into x minus our c, which is 1, all to the power of 2 divided by 2 factorial, plus f prime prime, remember we said this formula keeps on going, plus f prime prime of 1, which we had that to be 1, times x minus 1 to the power of 3 over 3 factorial. And we could keep carrying this as much as we want to. We've written our first term this, we've written this one this, we've written the other one this, and then the fourth one, which is this. Now we could simplify this further to give us x minus 1. Minus 1 times plus gives us minus x minus 1 to the power of 2 divided by 2 factorial is equals to 2 times 1, and this still gives us 2. So we could rewrite this as divided by 2. We have plus 1 times x minus 1 cubed still gives us x minus 1 to the power of 3. And we are dividing by 3 factorial. 3 factorial is equals to 3 times 2 times 1, which is equals to 6. So this gives us divided by 6 plus, and it keeps going on and on. So for the expanded form or the Taylor series of ln x at c equals to 1 gives us this expanded function we have. For Maclaurin series, the only thing we need to do in Maclaurin series is that c is always 0. So just put your value of c as 0 in every of your function you are dealing with. So thank you for watching today's video. Remember to like and subscribe.